All right, buckle up because we're diving into the wild world of carbohydrates. Simply put, carbs are biomolecules. Think fancy Lego bricks, made of carbon, hydrogen, and oxygen. They're like the energy currency of life. Forget Bitcoin, it's all about the carbs. We classify them based on size. Monosaccharides, single sugars, the basic building blocks. Disaccharides, double sugars, like a two Lego creation. And polysaccharides, big sugar chains, think a whole Lego castle. Basically, they're the fuel that keeps your brain from buffering and your body moving. Without them, you would not have the energy to watch this amazing video. Now, things get a little sciencey, but I promise it's not as scary as it sounds. These sugars can exist in different forms. We have aldoses and ketoses. Basically, sugars with different functional groups at the ends. It's what determines how it will react with other stuff. Like how you might have a sugar that's all about that aldehyde life, or one that's more into ketones. It's like choosing between a sports car and an SUV. Different vibes, different reactions. They can be in straight chains or rings. Straight chains are like those long highways, but rings are more common and stable, like a cozy loop where everyone gets along. But here's where it gets interesting. They have stereochemistry. Chirality refers to how molecules can have a mirror image, like your left and right hand. You can't superimpose them. It's like trying to high-five your evil twin through a mirror. DL configurations determine the way that the sugar molecule rotates polarized light, and D sugars are more biologically prevalent, like the cool kids at the sugar party. Plus, in ring form, we get alpha and beta anomers, which are different structures of the molecule. This may sound like a lot of jargon, but it's just fancy talk for how sugars can have subtle differences that change how they behave and what they do. Like how you and your evil twin look alike, but one of you is a sugar molecule and the other is not. There you have it, sugar shapes and chemistry that aren't as terrifying as a haunted house. Just remember, even the simplest sugars have their own personalities. All right, let's build on those simple sugars. Monosaccharides like glucose, your body's favorite fuel, act as reducing sugars. They link up through glycosidic bonds to create bigger structures. First stop, disaccharides, the dynamic duo. Sucrose is glucose plus fructose. That's your table sugar. Sweet but not your best friend in large quantities. Lactose combines glucose and galactose straight from milk. Unless you're lactose intolerant, then it's more of a plot twist. Now for the heavy hitters, polysaccharides. Cellulose is the tough guy in plants, providing structure and that crucial fiber that keeps digestion smooth. Starch stores energy in plants like potatoes and rice. Glycogen is your version, stockpiling glucose in muscles and liver for when you need a burst. So next time you're digging into pasta or an apple, remember it's all carbohydrate architecture at work. These structures fuel you, but moderation is key. Don't go overboard on the sugars, and always drink plenty of water.